Hi children, how are you? Hope you all of you are keeping fine in this lockdown period. Stay home, stay safe. You must have already got the first three sets of study materials and hope you must have learned the molecular formulas of different compounds and how to write chemical equations if you get a word equation for the chemical reaction. Now, this session I am going to show you how to balance a chemical equation. And why is it necessary to balance a chemical equation? Yes, it is necessary to balance a chemical equation to satisfy the law of conservation of mass. And what is the law of conservation of mass? You have already learned that one. Yes, it states that matter is neither created nor destroyed during a chemical reaction. Only the rearrangement of atoms takes place during the reaction. So what happens that time? Only mass of the reactants is equal to the mass of the products. Only rearrangement happens. Then mass of the reactants is equal to the mass of the products. That means the number of atoms on both sides should be equal. In a balanced equation, number of atoms on the reactant side is equal to the number of atoms on the product side. That means the mass of the reactant is equal to the mass of the products. So to follow the law of conservation of mass, we have to balance a chemical equation. I'll show you how to balance a chemical equation. Take one example. Carbon disulfide burns in air. The products are carbon dioxide and sulfur dioxide. Burning means reaction with oxygen. Reaction with oxygen. Okay. To balance a chemical equation, first step is write the left hand side. Left hand side means reactants and right hand side means products. Okay. Now, write the elements present on the reactant side. Carbon, sulfur, oxygen. Same elements present on the product side also. Carbon, sulfur, oxygen. Okay. Now, count the number of atoms present. Carbon, 1 atom. Sulfur, 2 atoms. Oxygen, 2. On this side, carbon 1, oxygen 2 plus 2, 4, sulfur only 1. Okay. Now, both sides, the number of atoms are different. So, for balancing means number of atoms on both sides should be equal. To make it equal, what will you do means you have to change the coefficients. Coefficient means number on the left side of the atom. Number on the left side of the atom. Here no number means coefficient is 1 only. Coefficient is 1 only. So, check. First atom carbon. Both sides one atom. Okay. Then next atom sulfur 2. On the left hand side it is 2 and here it is 1. So this side you have to make it 2. This one make it 2. To make it 2, what will you do? Put here 2. When you put 2 here, number of sulfur atoms also change. At the same time, number of oxygen atoms will also change. So here now the number of atoms, 2 2s are 4 plus 2, that is 6. So this one will become 6. Now, this side, see, here it is only 2 atoms. Left hand side only 2 oxygen atoms. So this one you have to make it 6. This one you have to make it 6. To make it 6, what will you do? 3 2s are 6. So put 3 here. Put 3 here. Then oxygen atoms 3 2s are 6. Now you compare both the sides. Carbon 1, here also 1, sulfur 2, this also 2, oxygen atoms here 6, here also 6. 1 2 6, 1 2 6. So equation is balanced. So now the balanced equation is carbon dioxide CS2 plus 3O2 gives CO2 plus 2SO2. Okay, this is the balanced equation. I'll show you one more example. Aluminium reacts with sodium hydroxide and water. The products are sodium aluminate and hydrogen. Sodium aluminate NaAlO3 plus hydrogen. Okay. So to balance the chemical equation, first step, write the left hand side, reactant side, and right hand side, that is product side. Okay. Left hand side, the elements present: aluminium, sodium, oxygen, hydrogen. Same elements on the right hand side also: aluminium, sodium, oxygen, hydrogen. Now count the number of atoms. Aluminium this side 1, sodium 1, oxygen 2, hydrogen 2 plus 1 3. This side aluminium 1, sodium 1, oxygen 3, hydrogen 2. Okay. Since the number of atoms are different on both sides, we have to make it equal. To balance the equation means both sides should be, number of atoms should be same. To make the number of atoms equal, what will you do? Change the coefficients. No need to change the subscript. Only change the coefficients. Subscript here it is 2, this one 3, it is 2. No need to change the subscript while balancing a chemical equation. Okay. So here check. Number of aluminum atoms, left hand side 1, right hand side 1, no need to change. Again sodium 1, here also 1, no need to change. Oxygen 2, this side it is 3. So left hand side you have to make it 3. To make it 3, what will you do? If you put 2 here, 2 oxygen atoms plus 1, 3. So this one will become 3, oxygen will become 3. Okay. When you put 2 here, number of sodium atoms as well as hydrogen atoms change. Okay. So number of sodium atoms now, this will become 2. And hydrogen atoms now 2 here, here also 2. 2 plus 2, 4. Now again check, here it is 2 sodium atoms, here it is 1. So this side, this one will, you have to make it 2. To make it 2, this, what will you do? Put here 2. If you put 2 here, number of sodium atoms, aluminum atoms and also the number of oxygen atoms will change. Okay. So now sodium atom 2, aluminum also 2, this one 2, oxygen atoms now 3 2s are 6. So here now again check 2 aluminum atoms, but here it is 1 only. So make it 2. What will you do? Put 2 here. Sodium 2, here also 2. Now oxygen atom here 3, here 6. So this one you have to make it 6. To make it 6, what will you do? Here, see here, if you put 2 here, 2 plus 2 oxygen atom, here also 2, 2 plus 2, 4 only. If you put 3 here, 3 plus 2, 5. If you put 4, if you put 4 oxygen here, 4 plus 2, 4 plus 2, 6. Then oxygen will become 6. If you put here. If you put 4 here. If you put 4 here, the number of hydrogen atoms also will change. Number of hydrogen atoms now you count. 4 2s are 8 plus 2, that is 10. Then this one will become 10. This side, but only 2 hydrogen atoms are there. So to make it 10, what will you do? Multiply this one by 5. If you put 5 here, 5 2s are 10. Okay. Now you compare both the sides. Aluminium here 2, this side also 2, sodium 2, here also 2, oxygen 6, this one also 6, hydrogen 10, here also 10. Now 2 2 6 10, 2 2 6 10. So the equation is balanced, and the balanced equation is 2Al plus 2NaOH plus 4H2O gives 2NaAlO3 plus 5H2. Now the equation is balanced. Okay. See children, you are the beginners. No need, you are the beginners, so I am writing all these steps. Okay. After practicing so many equations, you will be able to do this one in your mind. No need to write these steps. Okay. You can do this one directly. After practicing so many equations. Okay. Then you can be able to do like this. No need to do these steps. Okay. Now, somebody asked me the law of conservation of mass. Okay, what is the law of conservation of a mass? Explain with an example. This one, after balancing this chemical equation, you proved the law of conservation of mass. Law of conservation of mass states that mass of the reactants is equal to the mass of the products. When the number of reactants and number of products will be the same, that means mass of the reactants and mass of the products will be the same. I'll show you with simple example, one simple equation. Carbon plus oxygen gives carbon dioxide. Okay. Here, if you take a number of carbon atoms 1, here it is 2, here also 1, 2, 1, 2, 1, 2. Okay, number of atoms same, both sides will be the same. Carbon atom, the atomic mass of carbon atom 12 gram plus oxygen atomic mass is 16. 2 atoms, so 16 grams 2 into 2 equals, see, here carbon atomic mass 12 plus 16 into 2, 16 grams. Here this one also gram. 32 plus this answer is 44 grams. Here also 44 grams. That means mass of the reactants is equal to the mass of the products. That means it follows the law of conservation of mass. This proves that the law of conservation of mass states that matter is neither created nor destroyed. Only rearrangement of atoms takes place during a chemical reaction. Rearrangement of atoms takes place during a chemical reactions.